Okay, guys, look, I have a buddy. Hey, you right here? Hi, guys. Oh, look, she's so cute. Okay, so someone wanted to come on my lap today while we take notes. So we're gonna see how this works. Oh, I got scooped up. So today we're gonna talk about transforming parabolas. Where'd it go? There it is. Okay. So when we transform a parabola, first thing first is we have to find the vertex. So we're going to go ahead and use this parabola off to the side. And I know that it's not the best graphed one because I did this last year with my I did this last year with my smartboard, and that was before I had a touchscreen laptop, so it doesn't look the best. So step number 1 is find the vertex. Oh, there she goes. Bye. Step number 1 is find the vertex. So my 1 is at 3, 0. Bye, Fatty. Step number 2 is that we're going to substitute the that vertex into the vertex form that we talked about yesterday. So that equation was y is equal to a times y is equal to a times x minus h, and so the minus h is going to be the minus 3 squared plus k, and then the k is going to be 0 because that's where I'm located at. And that's where my y value is. So that's number 2. Number 3, locate another point on the graph. Okay, we have a convenient one right here. We're going to call it 5, 2. I know it's not exactly 5, 2, but that's where it's supposed to be. I'm going to see if you guys can see it. Okay. Not bad. Step 4. Oh, now she's attacking things. Step 4 is to substitute my point in for x and y. And when I say substitute it, I'm going to substitute it in step 2. So where I have that equation in step number 2. So where I see y, I'm going to put a 2. I don't know a. My x is 5. And I don't really have to add 0 because what's 0 plus anything? Alright, it's just itself. Okay, next we're going to go ahead and solve for a. So step 5 is going to be kind of several steps in one. So first things first is I know I can go ahead and subtract these guys. So I have 2 is equal to a times 5 minus 3 is 2 squared. Then I'm going to go ahead and take this guy and square it, which is 4. Now, we should know that a times 4 is the same thing as 4a. I want to get a by itself, so I'm going to divide by 4. So a is a half. Then my very last step, it's too dark, right? Is to write the equation using h, k, and a. So I already had part of my equation was y is equal to a times x minus 3 plus 0, because we got it in step 2. So we're going to essentially take step 2, and instead of a, we're going to put a half. Done. Okay, let's see another example. So we're going to find the equation for the parabola at the right. So first steps first is, where's my vertex? And I want my colors the same. So red, purple, green, blue, and pink. So my vertex is at 4, negative 2. that was my next color. Purple, I thought so. Step number 2. Put in my h and k in my equation. So y is equal to a times x minus 4 quantity squared. Now it's going to be minus 2 because this is a negative. Step 3 is find another point. So 5, 0. Step 4, plug in this guy for my plug in that guy for my y and my x in my equation in step 2. So 0 is equal to a times 5 minus 4 quantity squared minus 2. I don't know if you can see that. Can you even see that? Oh, sweet, you can. Okay. Now, for step 5 and on, we're going to solve this. So I want to solve for a. So I do whatever's in my parentheses first. So 5 minus 4 is 1. Good. Next, I'm going to go ahead and do my squared part. So what is 1 squared? Good, 1. So you have 0 is equal to, now what's 1 times a? Good, just 1a. Now last time I didn't have a plus or minus, so this would be the point in time where we'd get rid of it. So to undo negative 2, I'm going to add 2. Sorry, I don't want to go that far up. So I get 2 is equal to 1a, which means that a is equal to 2. And then in my last step is to put it all together. So y is equal to 2 times x minus 4 quantity squared minus 2. Okay. So the Narrows Bridge in New York has the longest span of any suspension bridge in the United States. A suspension cable of the bridge forms a curve that represents a parabola. The curve can be modeled with the said function right in front of you, where x and y are measured in feet. The origin of the function is at the base of one of the 2 towers that supports the cables. How far apart are the towers? Okay, so we need to find the vertex. And I'm just going to tell you that the vertex is at 2130, 0. Trying to make my parentheses look like parentheses. So that means someplace here is my vertex. And I've got something that looks like that's god awful. Give or take that. What we want to know is how far apart the towers are. So, if my vertex is halfway between that, all I do is take multiply that by 2. 4260 feet apart. Alright, go try your homework. I know, you're gonna have difficulties with it. So please, do not yell at me. Come ask me kindly.